For this lecture because this is what I actually want to be talking about, as I told you guys before, and really it gives us an insight into kind of what's going on in our brain. And I think you wouldn't necessarily be able to get all the information that's going to be presented today unless you took a lot of prerequisites and a lot of psychology prerequisites and were able to take a class called behavioral neuroscience, or if you took a bunch of chemistry and organic chemistry and molecular biology, and you were able to take basic neuroscience or advanced neuroscience. It's kind of funny at this school. By the time you can take a basic neuroscience class as a neuroscience major, you are probably in your senior year, and your neuroscience degree at this university consists of all of 2 classes. So it's just kind of funny. I think there should be probably some more neuroscience taught. Really the difference between getting a degree in molecular cellular developmental biology and getting a degree in neuroscience is like minuscule. So as long as we can talk about this more to you guys and to everyone, I think we're going to be happy. So I first wanted to just go through some basic divisions of the nervous system. Essentially, if it's not your brain and your spinal cord, you are in your peripheral nervous system. So when I go over here and I come and I pinch Katie right in the arm and she's like, ow, that kind of hurt. That was actually because nociceptors, or neurons in her arm, were actually going back to the bottom of her spinal cord, which were right here, then entering her CNS, or central nervous system, and coming back up into her brain. But the process of me pinching her arm, that was her peripheral nervous system. Yeah, I would look at these kind of divisions. The peripheral nervous system has several other divisions. We have the autonomic and somatic. Autonomic is kind of like, it's out of your conscious control. It's like, it's essentially doing stuff without you. The somatic is something like, that's allowing me to like go like that, like move my arm. And then, it's interesting because the autonomic nervous system has then 2 other divisions, and we're going to be talking about this kind of more like when we go into trauma, stuff like that. But sympathetic is like fight or flight. Like when I have to run from a tiger, my sympathetic nervous system is going to be activated. When my heart is beating and is very very calm, and I swear to God I'm not nervous at all, that's my parasympathetic nervous system. So some stuff to memorize and regurgitate. Basic ideas, I just want you guys to know that there's two basic divisions. Try and know this stuff too. Okay, so what is the brain? Well, according to Ramachandran, who is a world-famous neuroscientist, who we will be watching a video at the end of this lecture, and David Presti, who's actually going to be presenting at our conference, the brain can be regarded as literally the most complex system in the universe, and I'll explain why. So our brain is made of these things called neurons, or brain cells, and essentially there's 100 billion neurons in our brain, and each one of those neurons has 10,000 connections with other neurons. And so if we do the math, that's 10,000 to the 100 billionth power, and that number outnumbers the number of elementary particles in the known universe, and physicists have estimated that. So this vast complexity is really what is allowing us to be conscious, to be here, to be present in this moment in lots of ways, to be able to change, and at least we think so, until we come up with a better theory. So how is the brain organized? In lots of ways, it's like a machine where different parts have different functions. We're going to learn about how our amygdala is involved with the fear response, or how our hippocampus is involved with converting short-term memory to long-term memory, and so on. But there's a big caveat. Any part of the brain can do almost anything. So if I was to sustain damage to a certain part of my brain, other parts of my brain could actually make that up. And it's been found that while as neuroscientists we want to make things simple and be like, well, this part of the brain only does this function, oftentimes one part of the brain will perform multiple functions, and it's pretty confusing. So, moving on. So this is our cerebral cortex. It's part of the forebrain. We'll be talking about what it is. So these are different parts of the cerebral cortex. The cortex means the outer bark of the brain. And we're going to look at the 4 lobes really quick of the cerebral cortex. So the frontal lobe is like involved with complex planning, control of our emotions. It's definitely, you know, the system that you're going to be using when you're watching a really, really scary movie and you're like, well, I'm actually not going to go run out of the room super terrified because my prefrontal cortex now is telling me that it's chill. Like, those monsters are not going to fucking kill me right now. We're doing fine. So the other part of the brain is, or the other part of the cortex is the parietal lobe. It's involved with like touch, sensory integration. That's all I want you guys to know. Parietal, touch, bam. Occipital, the occipital lobe's starting getting towards the back of the brain. It's involved with vision. Temporal lobe does hearing and smell. So yeah, our brain is kind of organized like a machine, you know, in some types of ways. It's an easy way to kind of divide it into different sections. But again, we have to remember this caveat that any section of our brain can do literally almost anything. So that's why we've seen, you know, these, I think we've maybe all seen that photo of that girl who literally has half a brain. And when she was very small, she had to have half her brain removed, and she's a normal functioning human being with half a brain. Okay. Moving on. So the real question here is, how do we know what the different parts do? Well, anyone have any ideas? Yeah.
People with brain damage to a certain area that tells you what that area is.
That's a good one. That's the one I was going for. So there was this guy. His name was Phineas Gage. And I believe in the 1800s, Phineas was a really well-loved and well-liked human being. He was the director of his railroad crew that was working to build a railroad. I forgot which state it was in. And in order to build the railroad, you needed these dynamite charges that essentially you needed to get a metal rod. You would then get some sand. You would dig a little hole. You would put the dynamite in the hole. Then you would put some sand on top of the hole, and then you would get this rod, and you would like pack it down. And it was a pretty, you know, mundane thing. And one day, Phineas forgot to put the sand on top. And so he was packing his dynamite, and we can all guess what happened. The rod flew 50 feet the other direction. In the process, that rod had gone through Phineas's prefrontal cortex. Ooh! Now, while most people would have died from this injury, Phineas was unconscious, but then taken back to his house or whatever, and the doctor was able to revive him. He went into some sort of like coma for like a day or two, and then managed to come out. Now, Phineas was fine. He didn't die. He didn't have any sort of like fatal infection from this injury. He seemed to be able to walk around okay, but there was one huge difference, and that was that Phineas was no longer a really nice guy. Phineas was super impulsive. He couldn't control his emotions. He was really hard to get along with. And so this gave us this first insight to, oh, maybe this kind of front part of our brain is involved with our emotional regulation. So this is just a good example of that. Okay. Moving on. So some other forebrain substructures that I want to kind of call your attention to. There's just like a certain amount of like regurgitation, like memorization that we just like have to get through. I'm sorry, I apologize. I don't like regurgitation. We even have on our website that we try and promote education that is more involved than looking at PowerPoint slides. Well, at least this PowerPoint zooms everywhere. So anyway. So the thalamus in the brain is kind of like in the sort of in the middle, and it's like a relay center. It's essentially where like if I'm perceiving you guys right here first it's gonna, in my brain, it's gonna go to the thalamus before it goes to my visual cortex. So, or if I feel something like I pinched Katie, it's actually gonna go through her thalamus before it goes to a different part of the brain. The hippocampus is a brain region that we're actually gonna talk about in detail in our trauma lecture. And the hippocampus is involved with conversion of short-term memory into long-term memory. The amygdala, which is a really interesting brain region, is involved with the fear response. If you get like a poor kitten and you put a some sort of laceration in that kitten's amygdala, that kitten will not be afraid of anything. I guarantee it. You could literally just be like, rah! And it would not go, it would not do anything, it would have no fear response. And so it's a good indication that that brain region is involved with fear. So one thing to go off that, so if there's a brain region for fear, there's got to be a brain region for like happiness or like guilt or those emotions, right? Where is it? Oh, you have no idea.
Cortex?
What's that?
The neonatal cortex?
I think the happiness has something to do with the ratio of your left brain to your right brain, like the activity.
So here's the truth. We have no idea.